Good afternoon. Myself is Anuja. Today I started my topic is purpose of embedded system. See the definition of embedded system. What is embedded system? Embedded system is an electromechanical system which is a combination of both hardware and software. It performs a specific task. This called the definition of embedded system. An example of embedded system, you can see electronic toy, mobile handsets, washing machine, air conditioner, automotive control unit, and set-top box, DVD player, etc. These all are in your daily life. You see the example of embedded system. Say, actual topic is the purpose of embedded system. The purpose is how the embedded system we use and what is purpose is in detail. It is indicate major application or for a embedded system. What are the purpose? If anyone can do a work, what is the purpose of work? So in this context, the embedded system has some specific purpose. The purpose here we discuss for 6 types of purpose are there. First one is data collection, data representation, and data storage. How the embedded system we can collect the data and we can represent the data, and how we store the data in a embedded system, and that is a one purpose. And next one is data communication. Communication is also one of the major purpose of embedded system. And the next one is data signaling purpose, and the next one is controlling purpose and monitoring purpose. The last one is application specific user interface. See here one by one, and first we will see data collection, data representation, and data storage. Here the data can be text, the data can be voice, the data can be image, the data can be audio, video, or etc. Anything or signal. This all format of data can be we consider as a major data. And data collection and storage perform acquisition of data from external world. The data we are collect from the external world, and the data can be a text, the data can be a physical quantity, the data can be a video, data can be a analog or digital. So data collection is usually done for storage, analyze, and manipulation and transmission. And data, the collected data can be stored directly in the system, or if the data is not good, the data can be deleted instantly. This is the purpose of data. In your daily life we use and we operate the data in this way. For best example, the data collection and data storage and data representation, the embedded system example, you can see the digital camera. In digital camera, what you can see, if you took an image, and that image, if the image is not clear, you can delete it. If your image is clear and it is nicely, then you can store that image, and you can collect your memory for a after 20 years, after 10 years, if when you want, at that time you can see that your previous images. So this purpose, the digital camera we used in your data collection, data storage, and data representation. And next purpose is data communication. Data communication, embedded data communication systems are dedicated for the data communication, and data communication is generally possible from complex satellite to simple homemade system. And see the best example, in our daily communication signals are coming from the complex satellites to our home. We are using routers and Wi-Fi routers and switches hub like this. So these devices are collect from complex satellite data to our simple home household appliances such as routers and Wi-Fi devices. So in this way, we are getting the data in a easy in every home. Okay, and the data communication happen generally in two way. One is a wired media and one more is a wireless media. In wired media, we use the wires, and in wireless medium is nothing but wireless channel like Wi-Fi, GPS, GPRS, Bluetooth, Zigbee, etc. These all are, we can call the wireless media or wireless interface. And the network hub routers, switches, modems, etc. are the typical example of the dedicated data transmission embedded system. And the next purpose is data signaling purpose. Data signaling purpose, embedded system with data signaling functionalities are employed in applications demanding signal processing like speech, coding, synthesis, audio, video coding, transmission application, etc. These are the major application is inbuilt in the signal processing data purpose of embedded system. And next one is computationally intensive system employ digital signal processor. The example here we can see impaired persons are wearing the instrumentation. If the person is not listen others voice clearly, so that person, if the person is use a device that called signal processing device, so that signal processing device is it can process the signal like speech, coding, synthesize, and audio video coding in translation application. This application is performed in impaired persons with their wearing a mission. Next one is monitoring embedded purpose of embedded system. One is monitoring embedded systems coming in these categories are specially designed for a monitoring purpose. Measuring like digital CROs, digital voltmeter, digital ammeter, and logic analyzer, etc. These all devices are coming under monitoring functionality. And you in your daily life you can see the best example in a hospital, or in that we use different digital scanners and ECG, electrocardiogram machine for monitoring the heartbeat of a patient is one more example of monitoring functionality. And you can see in the picture the generally BP 125 80, and we can observe all those devices are monitoring purpose. And next one is a controlling embedded system with a controlling functionality are used for imposing control over some variable according to the changes in input variable. The embedded system with control functionality contain both the sensors and activator. Sensor is connected input of the device and activator is connected as a output port of the device. The best example you can see the controlling functionality of embedded system is in AC. In AC, in air conditioner is used for controlling the room temperature. Generally, we use the AC to control the room temperature. Is an example for embedded system with controlling functionality. In AC, what we do, First, we use AC. AC is generally we use to controlling the room temperature. In room temperature, generally if the room temperature is 50, then the AC is automatically on. The who will tell AC is on? In AC, we are using one temperature sensor. With the help of the temperature sensor, if the temperature is increased, the sensor is sense the it can sense the external environment in external in environment information, and it capture the external world temperature, and it gives to the AC's heart of the AC microcontroller. So with the help of the microcontroller, it can on when the temperature is increased. If the temperature is below 20, then in AC we use one temperature sensor, so that sensor is not at all respond by the temperature. Here you are using below 20 30, so that at the time that sensor is not working, but it not indicating any information to the microcontroller. Okay, the purpose is when the room temperature is increased, at that time only that sensor is activated. If the room temperature is below, at that time it's not give any information, it can't pass any information to the microcontroller. And the next one is characteristics of embedded system. Generally, the embedded systems have some basic characteristics. One is application and domain specific, and second one is reactive and real-time application, and the next one is operate in hash environment, and the next one is distributed functionality, small size and weight, power concern. These are the major characteristics of embedded system. So what is application and domain specific embedded system? Generally, the application and domain specific embedded systems are, see here, each embedded system has certain function to perform, and they are developed in such a manner to do intent functions only. That means if any embedded system we are designed, it perform a specific function. For example, see the micro oven. Micro oven is we used for only heating the food, or and you can see other embedded system like washing machine is there. Washing machine is do only washing our cloth, it doesn't perform any other activity. The embedded system, both are embedded system, where micro oven is embedded system, washing machine is embedded system. Both are different, both are categorized embedded system, but their functionalities, their application is domain specific. Domain mean one system performs specific a function, application or specific function, and same embedded system it performs other application or other specific task. Okay, and both systems are different in the domain. Micro oven is not perform washing machine functionality, and washing machine is not perform micro oven's functionality. Okay, see here, in each embedded system have certain functionality to perform. They are developed in such a manner to do intent functions only. They can't be used for any other purpose. Example, the embedded control unit of micro oven can't be replaced with the AC embedded control unit, because the embedded control unit of micro oven and AC are specifically designed to perform a certain task. And next one is reactive and real-time characteristics of embedded system. In embedded systems are constant interaction with the external world through the sensor and user defined input device. With the help of sensor and user defined input devices, the embedded systems are constantly maintain interaction with the external world. And If any changes in the real world or external world are captured by the sensor or input device in the real time, and control algorithm running inside the unit interact with a design manner to bring the controlled output variable to a desired level. The real time system operation mean the real time system operation mean the timing behavior of the system should be in deterministic behavior. The real time system operation is the real time operation should be the time stipulated in manner, and the response should be in a time oriented. For example, you can see when your digital camera is on within 2 seconds, you set your camera is 2 seconds and you go for giving the force for a image. So within 2 minutes the digital camera is click your image. So this is a real time operation, we can say. And same way, your generally you use a lift in your home or your any commercial area, you can see the lift there. We use real time operation and real time application. You see all example in your real time. And the next one is embedded systems characteristics. And embedded system operate in hash environment. The embedded system you can bring with us at any irrespective of your environment. The environment, it may be a hot environment, the if environment is a cold, the environment is rainy, if the environment is very hot, irrespective of your environment, but the embedded system is safely it work. So this is the one specific characteristics we can say for the embedded system. The embedded systems design should take care of the operation condition of area where the system is going to implement. Example, you can see if the system needed to deployed in a high temperature zone, then all the components used in the system should be of high temperature grade. Okay, whatever the external environment condition is there, so with that environment is not affect in your embedded components or embedded system, but it can friendly work with the any environment. So this is one major characteristics of embedded system. And the next functionality or next characteristics of embedded system is distributed functionality or distributed. So it means that the embedded system may be a part of a larger system or many number of such distributed embedded system from a single large embedded control unit. You can see the best example ATM machine. ATM machine in ATM machine we have single function. One function is there. For example, see here. See, this is your big functionality ATM machine. ATM machine. Here first generally enter your name, username and all those. This is one functionality, single functionality. After that you collect the money, and after that you enter your password. Okay, and next it confirm you are entering amount is confirm or not, and next whether you are required the receipt or not. Like that single functionality we combinedly and we provide a large function. Okay, and this is the distribution functionality or distributed system, you can say here. The example, see, automatic vending machine, it contain a card reader, a vending unit, etc. Each of them are independent embedded unit, but they work together to perform overall vending function. Same as you can see the automatic vending machine, as well as you can see your ATM machine in general life. So both are distributed functionality only. And the next characteristics of embedded system is small size and weight. Less weight. We are generally the each and every customers or every user, we prefer embedded system like a small in size and less width. Generally, we select those product in nowadays. And you can check your mobile phone. Nowadays mobile phone are very lightweight compared to your previous old version. Okay, you can see the size, you can see the weight of the product and everything. You can change the style of those products. These are the major attractive attributes of the embedded system towards the user. So here we see the product size, weight, shape, style, etc. is an important factor in choosing a product. It is a convenient to handle compact device that can a bulky product. If you took a bulky product, it can be very hard to carry, and it can be very dangerous. And it can, if the product weight is very high, so you can't carry, and if that product is not user friendly and it is not a portability to you, whenever you carry the product, that is not at all suitable for somewhere or some cases. So every user should be preferred and should be select the product should be a less size, stylish, and shape, accurate shape, like this. Those user, by seeing those product style, the product is attract toward the user. And the next one is power concern. Power concern is major characteristics of embedded system. Power management is another important factor that need to be considered in a designing of the embedded system. An embedded system should be designed in such a manner to minimize the heat dissipation by the system. Whenever a embedded system design, the factor you keep in your mind, the product should be as much as less power dissipation is very less. So you concern power is very important factor. For utilization of power, utilization of your product, the power should be consumed very less. Okay, that is a condition, but is real time it's not at all. It is possible, but it is very rare case. Okay, in previous olden days, you can see your product, small product, it consume large memory. But in nowadays embedded system, it perform large application, but it consume very less power. In research, in coming generation or coming days, the scientists or researcher who are there in this field, they are they are uh, they are try to use less power and less power consumption. That is in going on research. So this is very major factor for the embedded system. And the next one is quality attributes of embedded system. Quality attribute of embedded systems are two types. One is a operational and second one is a non-operational. Quality attributes that need to be documented properly in any system design. Generally, quality attributes is indicate a non-operational requirement that need to be documented properly in any design system. Okay, there are two types. One is operational quality attribute and second one is a non-operational quality attribute. And see the first operational quality attribute. The operational quality attribute represent the quality attribute related to the embedded system when it is in the operational mode or online mode. The operational quality attributes are response, throughput, reliability, maintainability, security, and safety. These all are the operational quality attributes. And the next one is non-operational quality attribute. The quality attributes that need to be addressed for the product, not on a basics of operational aspects. Are they grounded under this category or non-operational quality attributes? Here we see the non-operational quality attribute: testability and debugging ability, and evolvability, portability, time to prototype and market, and the last one is per unit cost and revenue. So these are the non operational quality attribute.